Thank you so much. Good morning, good afternoon. It will depend on the time that you are joining the course. Today, we are concluding the ARA programming course from the beginner level to the advanced level, but we are looking for the practical applications of machine learning as the final course that we are going to make into this journey of ARA programming, where we started from the beginner level until now to the advanced level. So without taking much time, let's look at the machine learning applications just in a practical way. And we have seen the theory or the basic foundations of machine learning, and this is the time to see the practical case scenario. So let's continue to the practical case scenario. So we are going to make the practice by using the data set called default of credit card client. So the data set, it is from the cargo, and about the data set, this is also the a bit introduction about the data set so that you can understand what we are trying to look for. So the about the data set, it contains information on the default payment, demographic factor, credit data, history of payment, and bill statement of credit card client in Taiwan from April 2005 up to September 2005. So it has observations around 30,000. Okay, and it has 25 variables. That is a bit information about the dataset, and it is also come from the cargo. If you go to the cargo dataset and then you say that you want to look for the cargo dataset, you will see if you search the default of credit card client, you will see this information. So again, this is also the variables and its explanations for each. We have ID, limited bar. Those are also the variables and their explanations. I'm not going to take much time, and you have to refer on it for you to understand it, but this is also how the variables are also look like, and also their meaning on that variables. And this is containing the variables, and then for us, we are reading the data set. So what you have to do, it is as we have seen on the previous video, like especially for importing the data set, we have to set working directory where the data or where we want to save our result, and after that we are importing the necessary libraries, especially tidyverse for data cleaning and visualization, and read ARA for helping us to read the CSV format. So and then we wrote the data set where you will put the path of your dataset, like read underscore CSV something. And again, what you have to do, you have to view your first row. I was viewing the first row of my data, checking dimension, checking the structure and data type, summarizing statistics and column names to see way of how my name of my dataset also look like, and the value count. I'm trying to calculate the proportion of the data set for the default payment in next month. So I'm trying to see some basic analysis before we jump to the artificial intelligence techniques. This is explanatory data analysis, of course, that I'm doing. As the title of the slide called EDA, it means explanatory data analysis. I'm exploring my data so to understand it better. So this is also the data cleaning, because I'm checking for the missing value as a first step of data cleaning. Column sum, I'm trying to look for each column to see if I can have the missing value among them. So again, checking duplicate, I'm checking out trials by using also ggplot2. I'm also using boxplot to check the outliers. I'm also looking for the correlation using HatMap, especially for the numerical variables. And those are also the things, if you try to run this code, I was like looking for the correlation with the target variables, and after doing this, I was also trying to look for the categorical versus numerical variables, and I have also encoding the necessary variables. If I say encodings, where like you say that we have the variables like which is categorical, but because we are going to use it in a model, we can also transform it as numeric, just in terms of numbers, but to look like a numbers, but also having the purpose of doing a model. So here, after doing encoding and scaling, we have made also the we train the model, we are training the model by using caret package. And after creating this, we have also testing, we are understanding the invariance, we are looking for the imbalancing of the data in our model. After looking it, we started by building the first artificial intelligence model, or first machine learning algorithm. Because of the nature of the dataset, we have seen that it is going to be classification, because we are trying to see the credit risk, where we are looking for those who are going to pay the credit or not refuse to pay the credit. So who are not going to pay the credit, we are trying to see the probability that those who are asking the credit, which probability that they are going to pay without forcing them. So that's why, involving the categorical case scenario, that's why we use logistic regression as a part of classification model. So, and then we talking about the regression model, it's like when we are having the dependent variable, which is a continuous variable. But if it is a categorical and also discrete variable, most of the time we are using classification model. That's where we have logistic regression model. So those are also the logistic regression. We started on it, and then we see the summary of logit. We continue to it, and then we are assuming that you have the logistic model called the logit. So we are fitting it, we are predicting it, and then we are trying to see for the probability. And those are also the confusion matrix. Those are the confusion matrix. It is also helping us to see the true positive value we predict and the false value we can predict by using this model. And then we continue to create the confusion matrix. We are evaluating the metrics. After evaluating the matrices, to evaluating the matrices, we are looking for the accuracy. Not only the accuracy, when we say overall, if we say accuracy, it's like overall correctness, and precision, it's like how many actual positive were correctly identified during the process of predicting. And also looking for F1 score, it's like a harmonic mean of precision and recall. And also the record, it's like how many actual positive were correctly identified. So those are the key terms we use to have in evaluation metrics. And this is also the evaluation metrics code. This is the confusion matrix code, and these are also the packages above, like a caret, PROC. Those are the things we need to have so that the confusion matrix can work. And this is also the code. I'm not going to go each code by each, but for you, you have to copy and run it in other programming. You're going to get the result. Until this is also multiple model and comparison model to apply. We have a random forest, we have decision tree, support vector machine, and we are training all model and store the result. And after running all this code that we have here, we are looking for the imbalance. So the model is going to give us the output like this, like the model we have made. We have also used a gradient booster, random forest, a support vector machine, logistic regression, and also key nearest mean, and even decision tree. And after looking for those models, we have seen the accuracy, precision, recall, F score, and the ROC or IOC matrix. And after looking it, there is also the comparison of imbalance model and the balance model. That's what we have seen. And from that, we have seen that logistic regression, they are predicting the default credit to the extent of 71% compared to others. That's why most of the time we can also adopt what model that has the highest highest accuracy. So from here we look for the imbalance when the data are not balanced. That's what we call imbalance. The sometimes the observations are not equal, and also we used to say that we can prefer on looking for the imbalance. That's what we are talking about, and not always to look for those kind of things, but we have to train it based on the assumptions of imbalance. So that's what I have made, and then from that also I can continue to look for the necessary packages that is going to guide me once I'm trying to do this. Especially I was saying that I'm going to do the gradient booster, random forest gradient booster, and also those things that is related to that. And this is a code that I can use from using this. And I was also starting by defining the model as a function. Instead of running each and every model, I can also make the definitions or the functions that is going to help me to do those kind of things. So, and then what you have to do just to follow the procedures by copy this code and paste, and then you have to run. Once you run, you will get the kind of the result like what I have seen here, and this is what is updated while checking the things related to the imbalance of the data. So once you have the data which is balanced, as I said, if we say the imbalance, it is when we have like the data set and the observations are not equal based on, like if we are saying the credit, because we are talking about the credit risk, the probability that when we give the credit to the client are going to repay us or not. So because the number of the people who pay or not paying are not equal, that's why we say that we have the imbalance on the model, and that's why we say that we have to consider imbalance of the data. So that is also the correct output we have seen after looking on the imbalance of the machine learning model. And after looking for it, I think you understand the some applications of the machine learning, especially in other programming. And I think you have enjoyed the session since we started from the beginner level to the advanced level, and this is the final course for the other programming for the data analysis. I hope that you enjoyed the session from where we have started, and I'm continue to encourage you to do the practical exercise as much as you can so that you can prepare to do the final capstone project that is going to cover the advanced level before you get certified. So, and remember that to be able to get certificate you have to have 65 as a pass mark, but it's good to have more than 65 because it is also help us to see if you understand what we have seen from the beginning. And the capstone project for the advanced level is going to cover all the things from the beginner level to the advanced level. So let's continue to have a spirit of learning new things, and there is always room for improvement. So I wish you all the best. Have a good day.